Sir is a backend developer with keen interest in decentralized applications and blockchain. He is currently working on building enterprise solutions that help monitor and evaluate Kubernetes deployment and resources. He has worked mainly on Ethereum Tezos blockchain. Before moving on to the session, I want to inform all the participants that you are free to raise hands and put your doubts in the chat box. Post the session, we have a surprise for you. We will conduct a short quiz based on today's session and blockchain, and the winner will get prizes. So be excited and listen to the session. Now, I would like Sir to share his experience and expertise to make us aware of the technology. Over to you, sir.
Thanks a lot, Sunny. Awesome. Today's session is a basic introduction to blockchain and Tezos. I'll share my screen and I'll go through the presentation, and I'll share my insights on blockchain, and also we'll talk about Tezos specifically as a blockchain and how we can develop applications or decentralized applications on Tezos. So let me just share my screen. Let me know if it's visible.
Yes, sure.
It's visible, right?
Yeah, it is loading right now. Just a second. Okay. Yeah, it's visible right now.
Cool. Awesome. So before we jump into Tezos and DeFi applications and decentralized applications and all that, right? Let's talk a little bit about what a blockchain is, right? So I guess most of you have already heard of blockchains. Like recently, there has been a boom in blockchain, like cryptocurrencies and stuff, like Bitcoin and Ethereum and all these technologies. So you must have, or at least heard of blockchain and what it means. So I'll just give a quick brief intro to that, and we'll jump into the actual stuff that is Tezos. So if you search for blockchain, you'll probably find these three words as its basic or summarized definition. A blockchain is a decentralized distributed ledger. So there are some jargons here. Let's talk about each term separately. So let's start with ledger, right? So what is a ledger? Ledger is basically a logbook or registry where you store different transactions, right? So you must have, you probably, can find a ledger or a registry similar to this, in a local business or in a shop, right? If you go there, you'll probably find the business owner maintaining a logbook or registry of all the transactions that are happening every day, right? Like, and this logbook is basically used for the, to make sure that there are no discrepancies or any miscalculations later on, right? So if there are any discrepancies that happen in the calculations later on, the shop owner or the business owner can just go through the ledger and match all the transactions that have happened and get to a resolution of the problem, right? So that is what a ledger is all about. And blockchain is just basically at the core, it's just that, right? So in the blockchain, we are recording all these transactions that are happening on the chain, in the network, basically. So let's say these transactions can be like as simple as me sending X amount of tokens to someone else, right? So that is a transaction. So I'm sending 10 tokens or 10 BTC, for example, which is a huge amount, but just for an example, right? 10 BTC to someone else, right? So that is a transaction, and that is being recorded on the blockchain itself. And this data itself is later on used, can be viewed. It's also publicly available, so it can be viewed, and it can be used to verify transactions and make sure that the actual transaction actually happens, right? So that is what a ledger is. Let's then talk about decentralized, right? So decentralization is a concept where a system comes to a decision or a action depending on a consensus or a shared decision of all the network participants or all the system participants, right? For example, a good example would be, let's say you guys plan to, let's say, go out for a vacation, or you want to visit some place over the weekends, right? You and your friend group, right? So the decision of where you want to go to would probably be done through a discussion among the group, and then after a consensus, like after a voting or some sort of discussion, you're gonna decide that, okay, let's go to this place. So there is no single person deciding what the location of this visit would be, right? So that is what decentralization is actually, right? So there is no central authority that decides or determines the outcome of a particular action, or particular action. Yeah. So a contrast would be what you call a traditional finance system, right? In our banking systems, what happens is, if I want to send someone else money, right, I'll have to go through my bank. Like, I'll ask my bank, please send X amount of money to this person, which is whose account might be in the same bank, or in the same or a different bank, right? So all whether my transaction goes through, like whether I'm allowed to send the transaction, whether I have enough balance or not, everything is determined by the bank itself that I'm operating with, and that is a central authority in this case, right? But in case of decentralized systems, there I don't actually need to depend on anybody. It's directly from peer to peer, right? So that is what decentralization means. Distributed is basically saying that the ledger that we were talking about, right, the logbook that stores all the transactions, is basically stored across multiple nodes. It's distributed across multiple nodes, right? So in a blockchain network, we have multiple nodes that participate in the node, and do a lot of stuff, right? So the ledger that we are talking about, the list of all the transactions, or the history of all the transactions that have happened, is not stored on a single server or a single system. It's distributed across the node itself. So this reduces the single point of failure, right? Just like decentralization, where there is no central authority, or central governance kind of thing going on. Similarly, distributed also makes sure that there is no single point where things can fail. For example, again, going back to our traditional systems, right, where we have a bank that maintains or records all our transactions, and maintains our balances, right? So the balance that you see today, right, in your bank, is basically a number in the database of the bank, right? So for example, if the bank gets hacked today, or like the database gets compromised or something, right, the attacker can change the numbers in the database, and basically that will lead to that can lead to fund loss, or some sort of other issues, right? But in this case, because the data is not stored in a single place, right, it is distributed across all the nodes in the system. It's not practically possible for the attacker to change the data, because to achieve that, they'll have to gain at least 50% of the access to 50% of the network to do that, which is very difficult in established blockchain networks. So yeah, so to summarize, again, a blockchain is basically a logbook of all transactions that are happening, that is distributed. This data is distributed across multiple nodes in the network, and all the decisions that are done in the network, for example, whether a transaction should be allowed or not, whether a transaction is valid or not, all these decisions are done through a consensus of all the network participants instead of just a single authority. So that's what blockchain is. Why blockchain? That might be a question that you might be thinking right now. Like, we already have web 2.0, like a front end, a back end server, database. Why do we need blockchains, right? So again, coming back to the features of description of the blockchain itself, right? So we have decentralization. So there is no central authority that is governing the system. So there is no central point of failure, basically, right? So again, if we go back to the bank example, right, that we're talking about a few minutes back, right? So in that case, if the bank goes down, if the bank gets corrupted, the bank gets hacked, you are at a loss, right? Like, your data is at a loss, your assets are at a loss. But a decentralized system like a blockchain, you don't have that problem, because there is no single authority that is governing the system. Everybody has equal rights in the network, right? So it's much more robust in that sense. We have immutability, because the data is distributed across all the network, all the systems, and a transaction that happens once is recorded in the blockchain, right? So you cannot practically update the transaction or change the transaction that has already been recorded in the chain. And similarly, hacking the database or like the data that's there, right, is not also possible because it's distributed across multiple systems. So gaining access to all the systems and changing the data is really difficult. So your data is immutable. Then we have no censorship. Again, this relates to the decentralization principle. Because there is no central authority, you cannot be censored on the network, right? Censorship in this case means like if you're on Twitter, right, and if you post something explicit or something that is deemed to be inappropriate according to the rules, Twitter rules, right, your account will be banned, or your posts will be deleted, or something like that will happen, right? And that is possible because Twitter is a centralized system. Twitter has central control of the whole system, and they can practically do anything they want. But in a blockchain system which is decentralized, right, there are no central authority to actually block you or do such take such actions, basically. So it's there. So there is no censorship. Second, and lastly, we have trustless. So blockchain is trustless because again, there is no intermediary or central system that you need to trust yourself, trust to handle your assets or anything, or your transactions, because unlike the traditional system where you have to trust the bank to be fair and unjust, like fair and just for the transactions to be handled properly. In a blockchain system, there is no dependency on the system, right? So it's completely trustless. You don't have to trust anybody in the system to be able to make a transaction. So you can just send a transaction directly to from your account to someone else without actually having to worry about all this trust issues that come into centralized systems. Okay. So we talked about blockchain, right, and the different features of blockchain. But just doing normal transactions like sending tokens is not that useful. But it would become more useful if you can actually write applications that can interact with that users can interact with and do stuff on the blockchain. Right? So for that, we have decentralized applications. Decentralized applications are basically digital application or programs that exist on the blockchain or the P2P network, right? Instead of a single computer, and is outside the purview and control of a single authority. So a decentralized application, because it exists on the blockchain itself and runs and executes on the blockchain, what happens is all the features that we talked about the blockchain, right, like decentralization, immutability, no censorship, everything applies to a decentralized application too. So you get your decentralization, you get your immutability, you get your transparency, and all those things, right? So building applications on top of blockchain has a lot of benefits, right? You don't actually so the paradigm kind of shifts when you are working on Web 2.0 stuff, right? Like if you have a server, you have a front end. But in a Web 3.0 where you're basically working with decentralized applications, you don't actually have a server. Like you don't have a centralized server. You just write a program, which is, you can think of that program as a small script, right, which has different handlers, right? If you have written a server, about HTTP handlers and stuff. So similarly, a smart contract or a decentralized application code will have these different handlers to perform specific actions, and you just write that code and you deploy it to the blockchain. So the program or the code is actually going to run on the blockchain itself. So you don't have to worry about maintaining the server or all those things. Decentralized applications have grown, like the use case for decentralized application have grown over the years. Most popular applications that you can probably find is related to DeFi, NFTs, collectibles, basically, and third part, like other integrations, like with games and other systems, right? Like those are pretty popular right now. So for DeFi, you can if you're on Ethereum, you can look at Uniswap, Compound, like different protocols are there, right? So there are DEXs, decentralized exchanges, there are lending protocols, there are yield farming protocols, and all those things, right? So these are all DeFi protocols that are built on top of the blockchain and are basically decentralized applications. Similarly, we have NFTs and collectibles that are also on blockchains. Like currently, NFTs are a pretty big thing right now, and many artists are basically creating NFTs for their art and selling them, right? So popular NFT examples are NBA Top Shot. It was pretty big. Then we have Ethrox or something like that. I don't remember the name exactly, but there are different NFT projects and pretty popular NFT projects out there that are doing pretty good right now. That those are all decentralized applications basically. Um, uh, for the other external integrations like games, so currently games also have in-game collectibles or tokens basically which are actually blockchain NFTs or blockchain tokens, right? So the benefit of having NFTs as your in-game collectibles is that even if the game goes down, right, if the centralized game server goes down, the players who actually own the assets are still holding the ownership of that, right? Even if the actual game server goes down, they can still trade the actual NFTs, the collectibles on the blockchain, right? So that's a benefit of having blockchain integration into centralized systems like games and stuff. Okay, so before we go into smart contracts, is there any question that specific to what we have discussed till now?
Yes, the participants can raise their hands. We can unmute or they can write in the chat box for doubt.
There's someone raising their hand.
Yes, I will allow Kumar Som. Please. Kumar Som, you can go
I
ahead.
had a doubt. Yes, sir. I had a doubt regarding the servers. Like, for example, just few days back, some servers of EA was under DDoS. So it was of the game connection. So where only one player can access one server at a time. So where there will be any effect of blockchain.
So blockchains are more resistant to DDoS and these kind of attacks because again, a centralized system can have only that many servers, right? So for example, even if you are a big like somewhat of a big organization, you can have maybe 100 servers or maybe something like that to load balance and stuff, right? But in case of blockchain, right, if the network is established, you'll have thousands and thousands of nodes, right, on the blockchain that are supporting the chain, right? So even if you can DDoS some part of the network, the other part of there's existing nodes that will still continue to work. There are cases like where spam net transactions are being sent and stuff, but there are what you call safeguards in place that will prevent this from happening. For example, if you want to do a transaction on a blockchain, you need to pay gas, right? And depending on the network congestion and the amount of processing power that you want to use for that transaction, you have to pay the price of that transaction will increase, right? So attackers are kind of like this price increase and the cost of the transactions will kind of deter attackers from trying to DDoS the system. But it's still like there have been systems where like there are other blockchains like recently there was some downtime with newer blockchains that were coming up like L2s and other blockchain like Solana and stuff like which did have some issues, but they have been fixed and it's blockchain is a very what you call evolving technology, right? And there are safeguards and other solutions that have been thought of for these kind of problems. But in general, you don't see that level of DDoS in a blockchain system like you do in a normal centralized system, basically.
Some of the applications are like focused on one server only. For example, mass storage system cannot have that big of a network. Or sir, like if the application requires a large number of data, sir, can DDoS be applied over there also? Where like decentralizing or dividing the data is a bit more difficult.
So I'm not talking about centralized systems here, like I'm talking about blockchain specifically, right? So if you have a centralized system, obviously it can be DDoSed and there are preventions for DDoSing and all that for centralized systems. But for blockchain specifically, if you're using blockchain for some particular application and for storage also, like blockchain is not meant for storing large amount of data. You have other services like IPFS and stuff for that. But if you're using blockchain for your application and some kind of storage, distributed storage, decentralized storage for your storage needs also, the chances of it getting decentralized, like DDoSed or being under attack is much less than a centralized system. I guess that answers the question.
Yes, sir.
Yeah, we have a second question in the chat box from Pratik. So
Sure.
he's asking about, sir, about the NFT. How does it work?
Okay, I'm not sure what the question means. Like, what do you want to know about NFTs? Like, how does it work? As in, I'll just talk about NFTs in general, like what an NFT is. That might probably answer the question. So NFT is, or in full form, non-fungible token, right? Basically, it is a you know how do I put it? Let's say you have a token, right? So you need to understand the concept of token before you can go into NFT. So token is basically can either be a native token to the blockchain itself. So for example, Ethereum has, let's say, ETH, right? So that is a native currency, right? Some people also call it as tokens, but it's maintained by the blockchain itself, and there is no other source of getting these tokens apart from being part of the blockchain and mining and stuff, right? You can only get those tokens from there. But then we have also other tokens which are basically created by other users of the blockchain. So these tokens are also decentralized applications, right? So you can have, like, for example, on Ethereum, we have USDC, DAI. All these are tokens that are created by someone else. So these tokens can be created, minted, and sold and transferred and all those things, right? Similarly, something like these tokens, we also have some NFT, non-fungible tokens. So all these tokens that I was talking about, like DAI and USDC, are fungible tokens. So they have you can they have value associated with them, fixed value, and they're what you call divisible and stuff like that, right? But non-fungible tokens are usually used for stuff like collectibles and pieces where you want ownership of a object or artifact, right? So for example, NFT could be, let's say you draw something today, right? It could be digital art, it could be something like physical art or something like that, right? It doesn't matter. You take the picture, you convert it into a digital image, and then you want to sell that image, right? So you can sell that image in a lot of ways, but the most preferred way would be to convert it into NFT, right? So converting that into NFT means that someone can own that particular NFT and transfer that NFT as basically similar to the other tokens, right? So I can transfer the token, NFT token that I have, to someone else, sell it to someone else, right? Auction it to someone else, and the NFT token itself will have these attributes attached to this. So it'll have the image picture, it'll have the description, it'll have the any other specific attributes that you want to attach to that particular object that you're trying to mint as an NFT, right? So that's what NFTs are in general, right? So there are other use cases of NFTs also, like some have used NFTs to also ideas of selling buildings or property as NFT or something like that also. Those are also possible, but in general, the use case that we find is mostly related to art and collectibles. So hope that answers how TPS are increased. So TPS cannot be increased, like it is a network setting of the blockchain itself. There are different ways of increasing TPS depending on what network blockchain you are on. You cannot do anything about the TPS. It's the developers, the code developers who are building the blockchain itself. So for example, Ethereum has like sharding and all those things coming up in ETH 2.0 that will help increase the speed and the capacity of the network itself, right? So that could help increase TPS also. Yeah, I guess there are no other questions. Let's continue with the.
Yeah, sure.
Cool. So now that we have somewhat of an understanding of blockchain and decentralized applications, we want to know how we can build these applications, right? Write these decentralized applications on the blockchain. So to do that, we use something called smart contract. So a smart contract is basically a script that is stored on a blockchain that enables users to define custom rules and protocols for various purposes. Some typical examples of smart contracts include escrow accounts, DeFi applications, NFTs, and so on and so forth, right? So basically the concept of smart contracts is like I was also talking about previously, right? So decentralized application is just a script, right? You write some code for defining the rules and handlers for particular actions that you want to do, and you just deploy it. So that script that you have written is basically the smart contract, and that is going to perform all the run all the logic on the blockchain. So yeah, so whatever logic, whatever program, that whatever actions you want to take should be in that smart contract, like coded into the smart contract. So okay, now that we have some understanding of blockchains as DeFi decentralized applications in general, let's talk about Tezos now. So Tezos uh, is a is a blockchain again. The native currency of Tezos is Tez or XTZ. It is basically enables borderless transaction capabilities and smart contracts. It is programmable money, which removes the need for a middleman, right? So Tezos has both transaction based facilities, like as in you can transfer asset cryptocurrency, the base cryptocurrency, you can do that, but as well as you can write DeFi applications on top of it. So not all blockchains support this, writing decentralized applications on the blockchain. Like for example, Bitcoin does not support full-fledged decentralized applications, dApps on top of the chain, but chains like Ethereum and Tezos do support it with the normal token transfer facilities, right? Some other chains like let's say Hyperledger, right, which does not have this monetary or asset transfer facility, is just meant for writing decentralized applications. So there are a lot of various types of blockchains out there. Tezos is a public blockchain which has both decentralized application facilities as well as normal token transfer facilities. The features of Tezos include self-amendment capabilities using on-chain governance. So Tezos is able to upgrade through on-chain, a process called on-chain governance. So unlike other chains where, for example, in Ethereum we have hard forks. If you want to upgrade the chain to a version which is backward incompatible, we have a hard fork, and that can lead to multiple chains being created, right? So this has happened previously, like Ethereum has been hard forked, and their Ethereum Classic was created, and we have the Ethereum itself. So similarly, Bitcoin also had the same problem with hard forks. Like there are different versions of Bitcoin out there because of this hard fork, right? So on Tezos we don't have hard fork because of this on-chain governance. So if the chain or the blockchain needs to update, what will happen is basically a proposal will be injected, and the network participants or bakers in this case will vote on that, and will decide whether the proposal should be accepted or not. And once the proposal is accepted, the complete network upgrades. So all the participants will have to upgrade to the new version of the network, and that's how it works in Tezos. So this prevents hard forks completely, and that's a good thing because forking is a problem in general. So the decentralized applications that are there will have to decide on which fork to run on, and all those problems come into play, right? Yeah, so that's one feature of Tezos. We also have formal verification for smart contracts. What that means is that the code that you write, right, decentralized code, application code that you're writing, is formally verifiable. That means it is we can mathematically prove that your program is acting as you have expected. So for example, if your smart contract is just adding two numbers, we can mathematically verify it that yeah, this application is going to add two numbers instead of subtracting or something like that, right? So we can formally verify your smart contracts and determine like if your smart contracts are acting as you have planned. This helps reduce bugs and stuff that might creep into the application later on. But this does not mean that the code that you're writing is going to be completely bug free, because if there are logic errors or logical issues that in the contract itself, it will still be there, because formal verification only makes sure that your code is functioning as you want it to. But if there's a issue in the logic itself, the outcome will still be erroneous. Cool. So that are the two main features. But with that, we also have liquid proof of stake, which is a consensus mechanism of the network, right? So all blockchains work on a consensus mechanism. So for example, Ethereum, Bitcoin, Ethereum 1.0, Bitcoin, and some other Bitcoin-like chains work on proof of work, basically. That is a consensus mechanism that they use. So consensus is basically how the blockchain comes to a decision of whether a particular block of transaction should be added to the blockchain or not. So that is what a consensus mechanism does. And there are different varieties of consensus algorithms or mechanisms. Like proof of work is one, which is used by Ethereum 1.0, Bitcoin, Digibyte, Bitcoin Cash, and all these other chains. Then we have proof of stake, which is used by which will be used by Ethereum 2.0. All the L2s use proof of stake, Ethereum L2s. Similarly, Tezos also does use proof of stake, a version of proof of stake, basically. Then we have other consensus algorithms too that are coming up. I think Solana has proof of history. Then we have proof of authority and some other chains and stuff. So just talking about proof of stake, which is basically a consensus algorithm where the bakers or the network participants in this case, who are basically mining or creating these blocks that are added to the blockchain, right, are people who have to stake a particular amount of tokens, the base cryptocurrency, that is XTZ. In this case, they have to stake that a specific amount of that XTZ, which is I think around 8,000 minimum. So they have to stake that, and once they stake that token, they are eligible to bake or create these blocks for the chain. And obviously, for creating the block, they are rewarded with some XTZ in return, right? But unlike other proof of stake chains, where to be able to mine blocks or create blocks, you need to completely lock up your funds, the stake amount, and you cannot actually access it or transfer it for a specified period of time. In Tezos, we don't have that. What we have is basically like anybody can stake or delegate also. If you're not a baker, you can delegate it to a baker and let them stake the amount. So basically, in case of Tezos, the staking process is that you do not lock up your funds, so you still have access to the funds even if it's staked, and you can actually if you want, you can transfer them out anytime you want. So it's always in a liquid state. That is why it's called liquid proof of stake. Okay, so now let's talk about how to write smart contracts on Tezos. To write smart contracts on Tezos, we'll be using SmartPy. SmartPy is basically a Python library for constructing Tezos smart contracts. It comes with compilers that generates the Michelson code. So the actual code that runs on the blockchain is actually in Michelson, which is a low-level language for Tezos, and it's not common for developers to write in that language directly because it's difficult to do that. But you can still use high-level languages or abstracted languages like SmartPy, which is more intuitive because it's close to a language that you might be more comfortable with, like Python. If you already know Python, then it's pretty easy to pick up SmartPy almost immediately. If you don't know Python, even then it's pretty Python itself is pretty easy to pick up. So it should not be a steep learning curve. But besides SmartPy, we also have other different languages in which you can write abstract languages, like high-level languages, basically. We have Lego. If you're into functional programming, you can use Legolang, and different flavors of Lego like Pascal, Lego, and stuff. Also, SmartPy also has a version where you can write the code in TypeScript. It's called, I think, SmartDS, which was recently released. So if you know JavaScript more than Python, then you can also use that to write your smart contracts. So again, SmartPy being a Python library means by defining smart contracts, you will benefit from the full power of Python to iterate over data structures and libraries and stuff, right? But at the end of the day, you're still targeting the powerful low-level language, that is the Michelson language, which is also formally in Python. So to write smart contracts, we can do it in our IDEs, like local IDEs like VS Code and stuff, but the IDE support, like VS Code support or some local IDE support, is not that great yet. So we'll use SmartPy.io. That's a web IDE, which is very similar to Remix if you have developed smart contracts on Ethereum. So it's a web IDE, where you can write your code, and also at the same time you can deploy the code and test your code all in that IDE itself. So we'll be using that for the development purpose. If you want to learn more about Tezos and smart contract development, you can also look into Crypto Code School. It's a gamified version of learning, so you can perform missions and stuff, or play through the game and learn about Tezos and the smart contract process of building smart contracts and stuff. So in tools, we have the SmartPy IDE that we'll be using. Then we have the wallet extension that we'll be using to interact with the code that we write and deploy on the blockchain. So we'll be using Temple wallet. There are other wallets also like Galleon, Kukai and stuff that you can try out if you want. But we'll be using Temple wallet for this particular session. We also have the developer super pack, which is basically a bundled package where you have all the stuff installed for you. So we have tester GUI, tester CLI, which are basically used for interacting with the blockchain, from the command line or from the GUI. And basically you can do stuff, read the storage, get the contract and stuff like that. We also have bundled React, which is basically a packed web React application, which is having all the required, commonly required npm packages and stuff ready for you, so you can just start off building a front end and connect it to the blockchain immediately. We also have the explorers and indexes. So if you want to build scalable decentralized applications, you need to use these indexes for the front end, because fetching data directly from the blockchain is sometimes very slow, and for applications to have a good user experience, you don't want to wait that long. So that's why you need to use indexes. For indexers, you can look into Better Call Dev and the TZKDIO APIs for indexing. We also have Consul. Consul is also pretty good if you want to do more complex and robust queries. Consul might be a better option. Materials, we have again SmartPy as the smart contract language, and then for the front end, we will use some client libraries. For example, if you're writing a CLI or a Python client, then you need to use PyTezos. If you're using JavaScript, it could be front-end JavaScript or Node.js. You can use Consul.js or Tapito according to your requirements. Developer support, again, so you can visit all these links and you'll get to know more about Tezos. So developers.tezos.com, you can read about Tezos, Tezos protocol, even low-level information about Tezos if you want to go deep. But then besides that, we also have other references in Tezos.com for smart contract development and stuff. And then we have the SmartPy reference, which is a must if you want to develop on SmartPy. You need to go through that to get a hold of the language, smart contract language that we're using. Then Crypto Code School to learn more about Tezos and smart contracts. Tezos Stack Exchange, if you have any questions, go ahead and post it on Stack Exchange. You might probably find someone else has already answered question, so you can take a look at their answers. Then if you don't find answers anywhere else, you can join the Telegram group for SmartPy. If it's specifically related to smart contract, developing the smart contract itself, SmartPy, the group will help you out. Then we have our India Tezos developer group, where we have all the developers in the Tezos India ecosystem. So you can get support from there too if you have any doubts or issues. Then we have the docs for the client libraries, Taketo library and the Consul.js library. Cool. So that was mostly it. Let's dive into a quick hands-on for the smart contract development. So right now we'll be working on a very basic smart contract, and we'll be looking into how to integrate or deploy that contract and also integrate a front end to it, right? Interact with the blockchain. So for that, we have our application. So this is the application, the result, like the final application that we are trying to build. So it's a very simple application. There's a value or integer value that's being stored in the blockchain in the smart contract, and we want to be able to update that, right? So there are different functions that we have here. So if I want, let's say I want to update it to 10, I can just click on update and my wallet will pop up. I'll show you how to get the wallet and stuff also. But basically, once you get the wallet, you can connect the account that you want to use and then send a transaction. So once you send the transaction, you are basically done. Now, once the transaction is confirmed on the blockchain, you will see that the value has updated here too. So yeah, so let's see, like it will take some time to update the get the block confirmed and stuff. While that happens, let's go and set up our other requirements. So we'll be using smartpi.io/IDE as our development like IDE platform. As you can see, I've already written the code. I'll just go through the code and due to time constraints, I'll just quickly go through the code and talk through how the code works and stuff. And then we'll finally look at the client library where we are actually doing all these calls, right? So we can see that the value is updated from 0 to 10 now, and it's persistent. So if I refresh the page, also it'll fetch the data from the blockchain, which is still going to be 10. So yeah, so we'll look into the front end code that is interacting with the blockchain. Besides that, we have the better call dev open here. So we'll take a look at how to use an indexer. Like while developing, you want to debug something or do some stuff. You probably want to use better call dev for that. This will help you look at all the transactions that you're making and stuff. So it's pretty easy to use. Then we have the Temple wallet, which is the wallet that we're using, right? So you need to first install the wallet. So you can click on, you can go to templewallet.com and then click on install and get the wallet for your particular browser. So Temple wallet is a browser extension, just like if you have used MetaMask on Ethereum, that's pretty similar to Temple wallet. And to get a testnet account, right? So for development and testing, we need to get a testnet account. So for that, what you can do is once you get to the setup of the Temple wallet, you can go to import account and click on faucet file. So this will get you to this place where it's asking for you to upload or paste some JSON code, right? So what you can do is you can also find this link here. It's called faucet.tzelpha.net. Clicking on that will take you to a page where you can get a faucet file. So this faucet file is basically going to create an account for you, a testnet account for you, and will provide you with the tokens that are required for that particular account. So for example, I just created a faucet file. I can just take this faucet file and paste it in my, let me just open it up. Yeah. So I'll go to import again and faucet file and just paste in the thing and submit. So once you submit it, you will get a new account created for you with some amount of test tokens ready for you to use. So that makes the development pretty simple. So once you have the account, you will have something like this, like I have here, and you'll see the testnet tokens. So this is a testnet. We are working on GranadaNet right now, and this is a testnet of the mainnet. We also have the mainnet here, but we are using this GranadaNet. And you have the test tokens here. These are of no actual value. These are just dummy tokens that you can use to play around with your smart contract and deploy contracts and stuff. Cool. So once you have the wallet set up, done properly, what you can do is you can start working on the contract itself. So so I was talking about how SmartPy is very similar to Python and just basically a Python package, and all you're writing is Python code, right? So you can see it here. So to start off with the smart contract, you first need to import SmartPy into your file. So this is basically importing the SmartPy package into the code, right? And then if you want to create a contract, so in SmartPy we define contracts as classes, right? So if you want to define a contract, what you do is you create a class and then you pass in the sp.contract as a parent class, basically. So this is basically very similar to a Python class that you're using, right? You can also have normal classes that do not implement or do not inherit sp.contract. So those classes are static, or basically only used during the compile time and cannot be used in runtime. So basically anything that you want to have, like any logic or any specific code that you want to run on the blockchain, needs to be inside a class that implements sp.contract or inherits this sp.contract class. Cool. Then we have if you're aware of if you have worked with Python, you probably know the init constructor that we have. So in case of a smart contract class, what we are doing is in the init uh, in the initialization of the constructor function, what we are doing is we are defining the storage of the contract. So to define the storage of the contract, what we do is we call the self.init function, which is going to define our contract, and any data that goes inside this is basically going to be stored on the blockchain and can be updated on the blockchain. So in our case, in this example, we have just stored a single value called stored value, and which is an integer that we are taking from the constructor itself. So we are passing a default value to the constructor, and that is going to be initialized as a default value for the storage. Moving from the storage, now we go into the actual entry points, right? So let's say if I go back to the application, right? So we saw that there are different functions that we are calling. Different functions have different actions, right? So we have the add action, we have the multiply action, we have the update action. So all these are different actions that we are trying to perform on the blockchain on the particular smart contract. So all these actions need to be a separate entry point. So you can see here we have an entry point for each of the actions that we're taking. So for update, so to define an entry point, we need to first add this decorator, which is sp.entryPoint. This tells the SmartPy compiler that this particular function is not a normal method, but rather an entry point of the contract itself. So yeah, so here we are. What we are doing is like we are we create the update function and define it as an entry point, and then we take in parameters, right? So these are the parameters that we are sending, that we're going to send from the client to the contract for it to operate on. So in this case, we are value, which is a single value in this case called value, right? So you can have anything in this thing, like it is. So in case of Python, this is basically like a dictionary kind of, right, where you have different values stored into the different values stored into this particular params itself. So we are just having a single value in this case, and we are updating that value and storing it in the contract storage itself. We have updated this contract storage with the particular value that we're getting from the params in this particular function. Similarly, in the multiply function, we take a params and then we multiply the value that is being passed in the params with the one that is stored in the contract. And finally, in the add function also, we do the same thing. We just, in this case, we take two params instead of single param, just to change, to show that you can pass multiple params also. So we are passing in two parameters in this case instead of single one, and we are using that and adding it up with the one that's there in the existing smart contract. So that's mostly it for the actual logic of the smart contract. This is a very simple contract, but you can write more complex contract, more complex logics, and you can take a look at the different templates that are already available and examples available in SmartPy. So what you can do is you can open up SmartPy and look at the different examples that are there and also the reference. So for example, we have the documentation here, so you can take a look at the documentation to get a better understanding of how SmartPy works, all the different syntax and everything. You can just look at that and you'll get the documentation. And also we have examples and everything here, so you can take a look at the examples that are there. There are different example contracts that you can look at. We have NFT contracts, we have chess, we have simple contracts also. You can take a look at that and learn from that and build your own more complex contracts. But yeah, so that's mostly it for the smart contract part. But to run the contract itself, I need to write the test cases. So without the test cases, SmartPy will not allow you to simulate or run the basically compile it also. So if I run it right now, it will throw me an error. Yeah, it will say that there are no tests there. So you need to add the test to simulate and test out the contract, right? And writing tests is very important because any code that you deploy on the chain, right, is immutable, just like the blockchain itself. So you cannot update the smart contract that you have deployed. So you need to be 100% sure what you are deploying. Yeah, so in the test, what I'm doing is pretty simple. I'm just creating a instance of the storage contract, and it is very similar to how you initialize a Python class and use it, right? So I'm doing the same thing. I'm initializing a storage and then setting up the scenario. So this is basically what will simulate the contract calls, even though we are not actually deploying the contract and everything. it will simulate that for the test cases. And once I have the instance and I've created the environment for the simulation, what I'm doing is I'm calling the different entry points. So I'm calling the update function with value 15, and then I'm also calling update function with 25. Then I'm calling multiply. Then you can verify whether, to make sure that your contract is working, the logic works, you need to also verify it. So you can do a scenario.verify and check the data that is being stored in the contract matches with your expectation. So in this case, it should match with 50, and that is what I'm checking. Then I'm making another entry point call for add, and then again verifying that the data matches my expectation. Okay, so now that I have the tests, I can go ahead and run the code, and once it finishes, you can click on output only. So if let me just go side by side. So here is the code, and here's the output simulation of the code, right? So here we can see the SmartPy code that's there, the storage, the types and everything, the definition, and also we can see the different contract calls that we have made. This helps in debugging and stuff also if you are testing and if you have any errors and stuff. But what we're interested in more is deploying the contract. So to deploy the contract, you can use the client libraries that I talked about, Constant.js or Taquito, to write your own deployment script. But a much more simpler way of doing it is to just use this inbuilt deployment option that you have with SmartPy. So you can click on deploy smart contract, and it's going to take you to this page. You can select the appropriate network you want to deploy to. So right now I'm going to deploy to Kubernetes. I can just do that, and then I can add my wallet. So this will connect my wallet, which I'll be using to deploy my contract. So deploying a contract is also basically a transaction made on the blockchain, and I'm using this account that I have right now for that particular transaction. Then you estimate the RPC, and then finally just click on deploy, and you'll get the wallet pop-up, and you can sign the transaction, and it will basically deploy the contract. Let me just deploy it. Yeah, once you sign the transaction, you'll see something like this. This is your contract address. Once there is at least 2 or 3 confirmations, you can actually take this address and put it in the better call dev thing, and this way you can see your contract. So right now I think we don't have, we have a single block confirmation, so we'll wait for a few more seconds and we should be able to see the contract. Okay, it's taking some time for it to load, but basically what will happen is once you have a few more confirmations here, you can just go and search for the thing, and you'll see the contract coming up. I also already have deployed another contract, the same contract but just a different address, so I can show that. So this is the contract that I have deployed previously, and if I search for it, you'll see that there's a contract coming up, and you can click on that, and that will take you to the actual contract, and you can see all the transactions that have been made, the storage that is, the data that's there in the storage, and the actual Michelson code that's there. You can also interact with the contract through this interact tab. You can send the transaction, the data, and everything from here itself. So yeah, so that was the contract deployment and contract, writing the contract part, right? But now we need a UI that will interact with the contract itself, right? So for that, what we'll use is we'll already have built a client, simple client in this case. It is a very simple React app created with create React app, command line tool, right? And in the package.json, I have only installed 2 packages apart from all the default ones that are installed by React itself. So I'm using Taquito as a JavaScript client for interaction. You can use console if you want. You can take a look at the documentation of each of the packages and determine what you need according to requirements. But in this case, I'm just using Taquito. So the package that I'm using is a Taquito/Beacon wallet and the Taquito/Taquito package. The Beacon wallet package is basically used for the interactions with the wallet. The Temple wallet transaction that you saw, right, was actually done through the Beacon wallet package. But apart from that, any other blockchain interaction, like fetching the storage, making RPC calls or something like that, is done through the /tucky2 package itself. So in the code, if I go to the code, I have a very simple architecture here. So we have an app.js, which is holding all our basic UI stuff. We have a simple form that's there, which is having our different input fields and different buttons for different actions. So each of the buttons are hooked up with a particular function that's connected in the library directory. I'll go there in a minute. So apart from that, we also have our library section where we do some actual blockchain interactions. So all the blockchain interaction happens here. So we have a config.js, which is basically storing our configurations for the application. So this makes the application a little bit more simple to build. You have your RPC network, which is basically stating what network or the RPC node to use for the transactions and stuff. We also have the network specification for like which network we are deploying. So right now I've set it for GranadaNet, but if you're deploying on mainnet, it will be mainnet, or some other network, then it will be some other network, right? Then we have the contract address that we have deployed. So I'm using this one, which I deployed previously, and all the contract calls are going to go to this particular contract itself. In the connect.js, we have the wallet connection settings. So when I call this function, I'm basically creating an instance for the Beacon wallet. So Beacon wallet is a standard of connecting Tezos wallets, right? So Beacon allows you to connect with multiple different wallets across different platforms and stuff, right? So that's pretty useful. But you can also use specific wallet packages. Like Temple wallet has a package of its own that you can use, but it's best to use Beacon wallet because it allows you to connect with multiple other wallets at the same time. So yeah, so once you create the Beacon wallet, you can just request for permissions from the user. So requesting permissions is like this allows the user to authorize the application to make transactions and stuff, right? So you want to request permissions first, and then you can use the wallet. Once the wallet is created, you create a, like in the app.js, you can see the wallet creation being done. And once the wallet is created, what I do is like you set a Tezos instance. This is a Tucky2 instance that is being created first in the code. And once the Tezos Tucky2 instance is created, we set the wallet as the our way of connecting to the blockchain. So the Tucky2 also allows you to do in-memory signing and stuff. So basically, you don't need to use a wallet. You can just paste in or pass in your private key, and that would also be fine. You can use the in-memory signer to sign transactions instead of using the wallet. But in this case, we are using the wallet instance to sign the transactions. So we'll set the wallet provider, and then we are calling the different functions on the blockchain. The different functions on the blockchain are stored in the interact.js file. Here you can see all the functions. Like I have different helper functions for each of the action that I want to do. So I have the update call, the multiply call, the add call, right? To actually make a call to the blockchain, what we need to do is basically we need to take the Tucky2 instance or the Tezos instance that I just showed in the app.js file and fetch the contract. So in this case, what I'm doing is I'm calling Tezos.wallet because I want to use a wallet provider for our calls, and then I'm calling the contract. So this basically fetches the contract from the blockchain and all the interface for the contract, like all the functions or entry points that are there on the contract, and everything is being fetched here. And then once I have the contract, I'm just calling the method on it. So the update method is the one that we have here, right? So this is the update function that we had. We are basically referring that update function when I call the update function here. So this will create a transaction for that particular update entry point that I have in the contract. Similarly, once the call is done, I'm just sending it to the blockchain, and I'm waiting for the transaction to be confirmed, and that's it. Similarly, for the multiply, I've found the contract, called the multiply function, and send the value to the blockchain, and then I waited for the transaction. And for the add, because there are two parameters in the add function, I have to pass in two parameters in the add. And once we pass the two parameters, you can just call the send and similarly wait for the transaction to be valid or confirmed. So these are the functions that we are using to interact with the blockchain, and this is how you in general interact with the smart contract entry points. You get the contract, and then from the contract you call the function that you want to invoke. Apart from that, we also have the get value function, which is basically getting the contract storage, right? So in Tezos, what happens to if you want to read the contract data, that data that's stored in the contract, you need to get the complete contract storage, and then you can parse it and read the data that you need specifically. So in this case, what I'm doing is I'm doing the same thing. I'm getting the contract instance, and then I'm calling the storage function on it, which will basically get me the storage associated with that contract. And once I have the storage, I can read the data from the storage. So in our case, we have a very simple storage that is just a single integer, so we can do this. But if you have a more complex storage that has multiple values and stuff, then you need to probably parse the storage and specifically take what data that you need from the storage data that you're getting. So yeah, so that's mostly it. We are almost at time. If there are any questions, we can take those up. I'll share the link. So this is the link to the repository that has all the code. I'll paste it in the chat for everyone else to take a look. I'll also share the slides. You can take a look at the Cool. I think that is all from my side. If there are any questions or any other things that you want to discuss, we can take those up, or else we can wrap up.
Yeah. So if participants have any doubts, they can put in the chat box or they can raise hands. I hope there is no doubts. So we can conclude the meeting, I guess. Yep.
There is one question in the chat box.
There is. Okay, sir.
Yeah. So proof of stake is so in general what you find, like when you search for proof of stake, what you'll get is probably delegated proof of stake or something like that, right? Where the user has to, like the person who's staking, right, has to lock up the funds for a specific amount of time, and during the lockup, that period that you're locking up, you're not allowed to transfer the funds or anything, so you're stuck with that, right, for that particular period. Only after the particular period is over, you can take out the funds and work with it. But in case of liquid proof of stake, the concept is that you don't actually have to lock up anything. Once you stake, that is actually still in your wallet, right? So what I can do is, like as a normal user also, even if I do not have 88,000 Tezos that is required to be a baker, what I can do is I can delegate my Tezos, that minimum amount of Tezos that I have, to some other baker. And that baker, what they can do is use my Tezos also in the baking process. And that way I can earn some rewards, that share of the reward that the baker is getting from their baking process. So in this process, right, of delegating, right, I don't actually send, let's say I have 100 Tezos that I want to delegate out. I don't actually send that 100 Tezos to the baker, right? Or I'm not even locking up it for a specified amount of time. I have the Tezos in my wallet and accessible to me throughout the time. And what I can do with it is, like at any point in time, like if I want to transfer it to someone else, even in between the staking process, like the whole process, I can do it without actually having to wait for that specific amount of time. That is the main difference between normal proof of stake and liquid proof of stake process. Hope that answers the question. Cool.
So there is an announcement for those who don't know. If you build a best Tezos app, you will get 20,000 rupees. And if you build a Flutter Tezos wallet app, then also you will get 25,000 rupees. So these are the sponsored tracks from Tezos. And if you built in the startup saga. So now vote of thanks. So the session was really amazing. It was very insightful session on the Tezos and blockchain. I'm sure that the audience must have also enjoyed it. Thank you so much, sir, for being here and sharing your valuable time here. Now,
thank you, everyone. Thank you for being a great audience. Thank you.
Now I would like to request the participants to stay and attempt the quiz. It will be open for 10 minutes only from now, for which the link will be shared in the chat box. So I will just share the link in the chat box. It will be open till 5:16. So all the best, and thank you all for joining, and have a nice evening.